So we start. I will just. Hello, everyone. Now it's time to start for the next speech. So I will just let the speaker introduce himself for this very nice talk. So I just let the word to him. Thanks to be here, and a little bit of housekeeping. It will be 35 minutes of speech, 5 minutes of Q&A. And so if you have questions, just take notes, and we will make all the questions at the end, so he will be able to go through the speech properly. Thanks.
So, thanks for coming, everybody. I am Apostolis, and we're going to talk about various challenges you will have to face, various things you will have to do when you target an international audience as a developer. First of all, I work for Transfex, which is a localization management platform, so we deal a lot of times with such things. So, first things first, let's talk about Unicode. If you want to target international audiences, people from all over the world, the first thing you have to make sure is that your application can handle strings written in their alphabets. And this is where Unicode kicks in. So, can anyone tell me what this long sequence of bits means? Okay, I guess nobody. Neither the computer can't. The computer can't tell either. As far as the computer is concerned, this is just a series of bits, and this is what the computer sees actually. It doesn't know anything about numbers, anything about strings, anything about Unicode, UTF-8, whatever. And this is why we have to tell the computer what this thing is and how to handle it. And this is actually where encodings kick in. So what's a character encoding? A character encoding is basically just a map of a sequence of bits to a single character in an alphabet. I'm sure you all must know of one-character encoding. The most well-known is ASCII, which is a very old one. ASCII is basically a 7-bit code. This means that ASCII uses 7 bits to represent its character. This means that it allows for 128 different characters, and these are barely enough for the English alphabet. And this is the main problem with ASCII. It's built just for the English alphabet, which might be cool for us developers, because when writing software we mainly use English, but it can't be used for strings that are used by that are seen by our users. Sorry, because ASCII was mainly built for English, for the English alphabet, and because it is a 7-bit code, and there's 1 bit in a byte still useless, many people try to use that bit to create extra encodings. These are the so-called ISO 8859 whatever encodings. So there is a specific encoding for each language, but the problem then is that how do you represent characters which belong from different alphabets in the same document? I mean, for instance, the ISO 88597 encoding is for the Greek alphabet. But if you use that encoding for your document or your application or whatever, you won't be able to represent characters which are from different alphabets. For instance, for Chinese. Actually, there's no ISO something for Chinese, as far as I know. And that's why Unicode was created. Unicode is just an assignment of every possible character in every possible alphabet in the world for every language, or most of them. And it assigns a unique code point, basically a number, to that character, which is uniquely defined. For instance, these are 2 examples of code points. The first one is for the Latin character A capital, and Unicode says that the code point for this one is 41. And the other one is for the Latin character A, the lowercase, which is 61. So Unicode is just this thing, mapping characters from various alphabets to just a code point. Sorry? Okay. So many people confuse Unicode with UTF-8. Actually, UTF-8 is just a character encoding for Unicode. Unicode is just that big list of characters and the code points. UTF-8 is the way to tell to the computer to the computer how these code points are actually represented in the hardware, which bits, which sequence of bits corresponds to a specific code point. So UTF-8 is just a character encoding for Unicode. There are other characters. Yeah.
I have a question about the last slide.
Yeah, sure.
Unicode maps all characters to a number. So accented characters
Yeah.
to be different.
Right.
E and an E with a cute accent and an E with a grave accent, they're all
Exactly.
characters.
They're different characters.
So there's no actual Unicode for an accent, which you might put on any character.
There is as well.
Yeah.
There are
Actually,
multiple ways of encoding characters in Unicode. Oh.
yeah.
Okay, so like E acute might also be like character number 675, but it might also be character 4 plus accent character.
Exactly.
Really?
It depends actually on how each alphabet represents its characters. But there are cases where that letter would say, actually this is for the Latin A capital. There is a Greek A capital, which is the same character. So sometimes the same letter might be a completely different one when it comes to Unicode. Yeah, so UTF-8 is just how you encode those things for the computer, so that computer can understand Unicode. There are other encodings like UTF-16, UTF-32, but UTF-8 is the de facto standard nowadays. So let's talk how Python 2.x versions handle strings in general. In Python, in the 2.x series of versions of Python, there are actually two classes for strings. One of them is the str one, and the other one is the Unicode. And they both inherit base string. So in Python 2.x, if you want to know if something is a string, you check if it is a base string, actually. So about the str class. Str class is an encoded string. It's a string which is encoding a specific encoding. By default, the encoding used is ASCII, but you can use whatever else you want. For instance, UTF-8 or ISO 88591 or Win7753, whatever that was in Windows, stuff like that. So this is an encoding string, a string with an encoding associated with it. That's the only way to represent it. On the other hand, Unicode strings are strings which are stored internally by Python. And they are stored in an internal representation. And they don't have any encoding associated with it. Python, for you, handles that a specific character is a specific code point. But we don't care how that is actually stored on disk, in the computer. So the thing is that whenever you want to save things to disk or send them over wire or whatever, you have to use an encoding. So that you can specify how these are stored in the computer, which bits are, what is the correct sequence of bits to send and to store and stuff like that. While Unicode strings are more or less used inside Python to represent all characters. And you only handle encodings whenever in I.O., in input or output. To represent Unicode strings, there is in order to mark a string as a Unicode, there is a prefix character, the U1, and the A string is now Unicode literal because it is marked with a U prefix. And by the way, whenever you write a Python source file and you want to use Unicode, you have to specify the coding of the file itself. By default, Python uses ASCII for that. So in the Python source file itself, you cannot use any other character other than Latin ones. If you want to use Greek or Cyrillic or Chinese or whatever, you have to specify that the coding for the file is UTF-8 or whatever else you want, but UTF-8 is the default. So, given a Unicode string, if you want to convert it, in order to find to understand the difference between Unicode and encoded strings, you have to understand basically that encoded strings are just like that. It's a string which is encoding specific encoding, like UTF-8. While Unicode strings are the Unicode representation of a string, and it is used entirely by Python. Having that in mind, it is easy to say that when you have a Unicode string, for instance, the variable u, in order to represent an str object, you have to encode it to an encoding. while when you have a str object S, which is encoded in an encoding, in order to get a Unicode object, you have to decode it from that encoding and convert it to a Unicode object. There are the basic functions, encode and decode, in the str and Unicode objects, which receive as an argument the encoding to use for the conversion. Okay. Yeah.
Does everyone get that? Because I spent ages trying to figure out what this all means, and it took me about 3 weeks. So if anyone's never come across this before, it might be worth spending a couple more minutes on, like, really, what is the difference between Unicode and a string or some bytes or whatever. So, like, hands up, everyone understands this completely.
Okay.
That leaves quite a lot of people that are a little bit confused. I don't know if you want to spend another few minutes just saying.
Yeah, sure. I don't have a problem. Okay.
Just from a part of stuff, if you want, we can move this part of the end, so at least he is able to move, and then he will explain more expensively at the end.
The thing is, there's another.
Thanks.
I saw in the program that there is another talk on Unicode, so I thought that maybe I should make it a little bit shorter to talk about other things as well. But we can always come back at the end and discuss this a bit more. But the basic idea, I'll just repeat it for once more, is that Unicode strings don't have an encoding with it. Whenever you store stuff on the disk, whenever you send them over the network, whenever you have to store them on file or whatever, you have to specify an encoding, because those things have to be stored in for the computer, and the computer has to know which bits to use to represent the specific character in the string. While Unicode strings are just something internal in Python, or they're represented internally in Python, and I think it depends on what compile flags you have used when compiling Python. Yeah, okay, we can get back to it at the end. So best practices here. The first tip is to always use Unicode strings in your application. It makes things a lot easier. It will make your application ready to be used by many audiences. People from all over the world, they can use whatever the alphabet they want in that application. And you will also be able to represent characters from multiple alphabets at the same time. So how do you... Yeah, but the thing is that whenever you receive a string or you have to send a string somewhere or store it, whatever, you handle encoded strings that have an encoding. So the basic tip here is that in input and then in output, you have to decode or encode the string. So in input, when I receive a string, maybe the user just enters something in a web form or in a dialogue or whatever, or there is a file that I have to read. I have to know the specific encoding of that file and decode it to get the Unicode string. And whenever I have to store something in a file or send something over the network or whatever, I have to encode it to a specific encoding. So, yeah. So in I/O, I have to explicitly know the encoding to use, whether that is ASCII or UTF-8 or whatever else. And another tip, which is very, very important, is that you have to test against Unicode strings. You have to make sure that your tests that you write for your application, there are Unicode strings in there, so that you can tell whether there are any Unicode decode errors or whatever else. And actually, it's best if you test for... I mean, there's no point in using Unicode strings that have only Latin characters in them. You have to have characters from the Greek or the Cyrillic alphabet or Arabic, Chinese, whatever. Okay. Oh, yeah. And there's also a module in the standard library of Python called Codex. The open function by itself, the built-in open function by itself, doesn't allow you to specify encoding to use when you open a file. So you have to use the Codex module and specify explicitly what encoding to use. By the way, use UTF-8. Most of the time, that's the correct solution. Okay. So let's go to the Python 3 section. In Python 3, the situation has changed because Unicode support in Python 2 point whatever wasn't exactly 100% correct. And there was a lot of confusion about Unicode and encodings and stuff like that. they changed the model a bit. So right now they have specified that instead of having an str object, which is an encoded string, and a Unicode object, you just have strings, which are actually the Unicode strings you had in Python 2.x, and you have bytes, which is just a series of bytes encoded somehow. By the way, the Unicode literals are back in 3.3, which is, I think, it is in beta 1. Just a few days ago, beta 1 was released. And this was done to ease the process of having one common code base for Python 2.x application and Python 3.x applications. Yeah, and by the way, you don't need the codex module anymore. So in Python 3, the same rule applies. Whenever you fetch something, you decode it to Unicode strings. You only use Unicode strings in your application. And only whenever you output stuff, you encode it to specific encoding. Okay. Now, the next step is about internationalization, localization. I don't know how many of you know these terms. By the way, the 18 there means that there are 18 characters between the I and the N in the internationalization word. And the 10 means that there are 10 characters between the L and the N in the localization word. This is the process of translating the software itself, translating it to different languages. I mean, mainly most of us use English as a language for the UI or whatever, and it somehow has to be translated to for different audiences that speak different languages. There are various formats to do that that handle internationalization for you. One of the most popular ones is gettext, which was created by GNU, and we're talking about PO files. There's another one called which uses TS files, which was created by Qt, by Trolltech, and it is used for the Qt toolkit. There's also YAML, which is used by Ruby on Rails, mostly, and there are other forms. Almost many languages have defined their own custom format. For instance, there are other formats for .NET applications, other formats for Java applications, and whatever. But whenever you have a choice, you have to use a real format, a format that was built specifically for internationalization purposes. I mean, YAML is just a generic markup language to define whatever you want. It's not a real internationalization format. And why would you want to do that? The thing is that a real format provides you, allows you to, has a couple of features that are actually very useful when internationalizing an application. For instance, a real format will have support for plurals. Most European languages, most Western world languages, have just two plural forms, the singular and the plural. But there are other languages that support that have more than two plural forms. For instance, Arabic has 6 plural forms. And yeah, and you want your application to be able to support that. Why is plural support important? Because there are strings in your application, your website, whatever, that will depend on a variable. For instance, you have to say that, you can say that I have 1 child, and there is another sentence which is I have 10 children, sorry. Which string to use depends on what is the number of children. And that is what plural support is actually for. It allows you to differentiate between these 2 cases, or 6 in the case of Arabic, and choose the correct string, the correct representation. Additionally, a real format will allow you will support context, so that you can say that a specific string is for a specific context. I mean, there's a string called OK, which is for a button. So it is a label, actually. It's not a part of a bigger string, which could be translated somewhere somehow else. It also provides support for comments, so that you can comment some strings, so that your translators can have more information on how to translate that string. And also provides support for suggestions, so that translators, if they are unsure of how to translate something, they can just suggest strings, and someone else takes the responsibility of actually translating it. We're going to talk about the gettext format, which is supported by Python, and many other languages, and there's also a module in the standard library for that. So to make the process a little bit more clear of how you make your application internationalizable, if that's a word, there are 5 steps that you have to do in when you write your source code. The first step, we'll see each one afterwards in more detail. The first step is that you have to mark the translation strings. You have to mark exactly which strings have to be translated and which not, so that the gettext format will know which ones to extract and which have to be translated. The next step is to extract them, and extracting the translation strings creates PO files, that's how they are called. Then you translate them, or your translators translate them. Afterwards, when translations are complete, you compile those PO files to create binary files, and then you just use them in your application. By the way, the example, I have the source code for the example in this URL if anyone wants to follow along. Come on. Yeah, okay. So, damn it. Yeah, sorry about that. Okay. So, we will now go through a very small application, which is an example of how to internationalize an application. So, there is a module in the standard library of Python called getText, which provides support for the getText format. The first thing you have to do is to call the getText.translation function, and there you have to specify the domain, the my application, the first argument, which is just it's pretty standard. So the domain of the translation can belong to different domains, but that's not very important. The folder, the directory where the translations are stored, which is under the locale in the current directory right now, and the third variable called fallback. The PO format has the ability to fall back to the source translation, the English one, if you use English, whenever a translation is missing. So if you have a translation in German which is only 90% complete, and a translation string is missing from that translation, getText is smart enough to just use the English translation instead, so that there are no strings missing in your application, in your UI. The last line is pretty typical. Whenever most users of getText choose to use the underscore character instead of calling the ugetText functions directly. It's much shorter. And it makes much more clear which strings are translatable in the source code. By the way, the ugetText function, there are many functions in the getText module. The ugetText one is one that handles Unicode strings. So that's the one to use. So how do you use that function, the ugetText function? Basically, this is how you mark the strings for translation. You just use the underscore, and inside the parentheses, because this is a function call actually, you just specify the Unicode strings you want to mark as translatable. You can use Python strings like whatever. They are normal Python strings, nothing weird going on. And you can also use the specify variables inside the variables to use and stuff like that. So whenever you have a string for translation, you just mark it this way so that getText knows and extract later. And this is how you specify strings which are pluralized. This is the UN getText function, which is the function used for pluralized strings, strings that have different forms depending on the plural form that is chosen. Here we say that this is the one to use whenever, for the first plural form, which is singular. This is the one to use for the second plural form, which is plurals, whenever you have plurals. And this is the variable that gets to decide, depending on the value of this variable, you will choose which one to use, whether you will use this one or this one. So if this is 1, you will choose this one, because you will say you have one child. But if this is something different than the one, you will use this one. Okay. Basically, you just provide because this is a pluralized string, you just provide the two strings that are the plural forms, the singular and the plural one. And depending on, and you also specify which variable gets to decide which one to use. In this case, if this variable is 1, like in the case of having the key John, it will use this one because this is 1, so it will go there. Okay, I will explain this in a bit. You have to see the profile itself. But this is the general, this is the way to mark pluralized strings. So, first you have to extract those strings. Given the source file, the l10n.py, you just run the xgettext format on top of that, and you create the app.pod file. The pod file is just a template file for PO files, from which you generate PO files for each language. Okay, let's open this for a bit. These are the headers of the pod file. These are just some metadata you don't really care about. Most of these, like the PO revision date, will be filled by the program itself. What you're mostly interested in is the car set, shown here, and this one, the plural forms. So, we saw earlier that somehow gettext has to know which one of these things to use. This is specified by the equation used here. Depending on that equation, gettext will depending on that equation, gettext will know which string to use from the two or more. And this is the actual strings. As you see in the PO format, there is for each string that we marked in our source file, there is the MSG ID entry, which is the identifier, the string we used in our application, and the MSG STR entry, which is the actual string to use as a translation for that entry. And this is the case for plurals. You can see here that this is the identifier for the singular, and this is for the plural form. Here, this is an array for the translations. Because English have just 2 plural forms, this is just 0 and 1. If we had Arabic, there would be here MSGSTR 2, 3, 4, 5, 6. 2, 3, 4, 5, sorry. Okay. So given the POD file we just extracted, there are a couple of commands we need to run to create the POD files themselves. Since we had specified in the beginning that our files will be located under the locale directory, we have to create those directories. And with the MSG init command, we just generate the POD files themselves for each language. For instance, this is for Greek and this is for Italian. In this step, we open the POD file to actually translate it, and running the MSGFMT command will produce the compiled files. So, like we said, to repeat the steps a bit, we first extract the files with the xgettext command here, and now we initialize the POD files from the template, translate them, and compile them to binary. The process is pretty standard, actually. So this is the header for a POD file. As you can see, some values were filled in by gettext itself. And here you can see the equation for the plural form. So what this equation actually does, given the variable, the third argument that we saw before, and its value, it uses that variable here in this equation to get an index. So if that variable had the value 1, it will be 1 different than 1, which is false, 0, and it will fetch the, sorry, it will fetch this string here. If it got another value, the equation here would give an 1 as an index, and it would use this one here, the second translation. Okay, and this is an example of how to execute it. So I used as an example the Italian. As you can see here, I didn't translate the plural ones, only the singular ones. This is for Italian. You can see that here it used the correct plural forms based on the variables, and since these weren't translated, it just fall back to it fell back to English, to the source language. Next step, next big issue with targeting audience from all over the world, people from all over the world, is about handling the time zones. This is a complex issue. Time zones are very complex issues, and they are actually complicated due to daylight saving times. I guess all of us know that at some point, most countries actually, at some point change the clock. They either go 1 hour ahead or 1 hour before, whatever. The problem is that the whole process is not standard. Throughout the history of time, the daylight saving times did not apply with the same way all the time. So there are countries that might have one way to change the time, or at some point, at some other points, they didn't change the time at all, whatever. And this makes the whole thing very complicated to calculate the time. There's also another issue with time zones and how it affects applications. Since at some point the time changes and it might go 1 hour ahead, there can be points in time which can never be true, can never happen. I mean, if at some point in the winter you go 1 hour ahead, all moments in that hour are not valid time. I mean, you went from 3 o'clock, you turn the clock to 4 o'clock, and 3:30 for that particular date is not valid. It can never happen. And there is another problem when you turn the clock 1 hour back. At that point, when at 3 o'clock you turn the clock to 2 o'clock, this means that the same time has happened twice. First time when you went to 3 o'clock, and the second time when you switched back and went to 3 o'clock again. This means that time zones are a mess. So the solution to this is to just use UTC. UTC is a standard time. It doesn't have any time zone. There's no DST for UTC. UTC is always standard thing, except for leap seconds. And all time zones are based on that. So the solution for time zones is to always just use UTC. And whenever a user enters the time in your application, you just ask him to specify the time zone explicitly. Given a time zone, you convert that to UTC and you store it as UTC, do whatever in UTC. And only in output, you convert it back to whatever time zone the user uses. Okay? Yeah, there's the daytime module, and it provides there are two objects that it provides for the date and time. One is called naive, which means that it doesn't have any time zone information at all, and the other one is called aware, which means it has time zone information. And you cannot mix them. You will either use naive or aware. My advice is just to use most of the times either naive when you don't care about time zones at all, or aware and convert everything to UTC. And only in input or output convert it to the local time zone. There's the PyTZ module with a database with all that information about time zones. This is the only way to know how the conversion can happen. I mean, if you want to convert the UTC time from the year 1953 in China from 3 o'clock in the night, you have to use a database for what the correct conversion was at that point. This is one of the things that PyTZ module provides. This is a simple example of how to use the two. You just create a daytime object from calling UTC now, which returns the time as a UTC, and from that, using the UTC time zone, you fetch a daytime object aware of anyway that has the UTC time zone, and this way you can convert it for EuroProm. Okay, and that's it.
Okay, so now we'll go with the question, and even me have a question this time. So who is the first one? Yeah. Then is the second.
Hello.
Hi.
I would like to ask, what's the difference between GMT and UTC time?
UTC has no time zone associated with it at all. GMT does have. I mean, GMT, even GMT changes. I think it changes time. It goes to UTC +1 during the summer. I think.
Okay.
But
Well,
that's the difference. UTC is the standard time, which has no time zone at all.
okay. Thank you.
Hi, can you hear me?
Yeah.
I'm wondering what other areas are problematic when it comes to internal or internationalization, other than time zones and like translation of language. Like I know there's like formats of like currency and stuff like that.
Yeah.
Can you mention a few, if it's possible?
Yeah, the thing with that is a problem of your platform. I mean, whether you will use the euro sign or the dollar sign for your UI, that's a matter of, when we're talking about the desktop at least, that's a matter of the underlying operating system. The underlying operating system will tell you that, for instance, for the thousands operator is a dot or a comma, and whether you have to use dollars or whatever, or whether you have to say that the format for the date is months/day, sorry, or day/month. These are big issues, but for desktop application at least, they are handled by the operating system usually. For web applications, that's up to you. That's whatever you want to decide. Yeah. It's very difficult to do it by yourself. So most people don't care. Okay. Yeah.
Hi. I think I had the most horrible time of my life dealing with the Unicode mess, especially on the web. Please tell me there is a way to detect which kind of encoding has
There is not. There is no way.
something,
okay.
even a 50%
There is a
sometimes
no. There's no way.
useful.
There is a cadet module, but that's just a guess. Nothing more than a guess. Sorry? Yeah.
Coding is a heuristic algorithm. You can guess.
CAR, CHAR, dead from character detection. But it is just a guess. If in doubt, just ask the user.
Any more question? Okay. All right.
When you use input strings, on what language you write your Python code? On what encoding you write your Python code?
That depends on what you specified in. Let me find it. Yeah. You specified it here with this line. Actually, this is an Emacs lines or whatever. But you specified here, and I put it on every Python file I write, and I just use UTF-8. That's the standard. ASCII.
Any other question? Okay, I have a question. So I prepare an application with the Unicode, and I try to translate everything from who knows what into UCS4, so UTF-32. Then from that, I created the translation with a code point, and from the code point I translated in ASCII using the code specification for the character. But I have to create a dictionary of 10,000 and something characters with a manual mapping. Do you know if there is another way other than map all the 100,000 characters of Unicode's stuff?
You have a source code with UTF-8 strings in it?
Yes.
And you want to convert that to ASCII?
Yes.
This is a lossless operation. I mean, since ASCII cannot represent everything in UTF-8, you will have to, everything in Unicode, sorry, you will lose information there. Yeah, I don't know any other way than, actually, the encode and decode functions take an extra argument which says what to do in case of characters that are missing from the target encoding.
Okay.
I'm not sure if this helps with your specific scenario.
Because I don't know the encoding, so I check the UTF-32 representation of each character, and they map to a custom dictionary that I prepare. So it was just similar question then. There is a way to sort the mess off, I guess.
Yeah, well, if I recall correctly, there are 3 ways that that argument in the encode or decode function works.
Yeah.
Either replace it with a specific character, either ignore it, or raise an error. There's nothing else you can do, except for doing what you do.
Yeah, okay. Thanks.
Okay.
Now we are going over time, so you can ask her.
Yeah, there's also a poster session. We will be there for transfix. If you want to ask anything about localization, Unicode strings, whatever, you can find me there in the afternoon. Okay?
Okay. Thank you
Go outside.
very much. So, just for information, if you weren't aware, there is a coding game, then you can win a MacBook. So just go down and check what you can do. And there is a poster session that is in the entrance of the hotel. And check there because there are very interesting stuff. So thank you again.